Hello, this is Dr. Mears. Today we are going to be learning about the probability of rolling two dice. So let it roll. Before we learn about two dice, let's just take a look at one and remember one dice. In one dice, our sample space is 1, 2, 3, 4, 5, 6. 6 sides, 6 numbers. So our total outcomes in our sample space is 6. This is a fair die because each side has the same probability of being rolled. A 1 has the same probability of being rolled as a 6. Okay, knowing that, let's find out the probabilities of each. We've done these before. The probability of rolling a 1, there's only one out of 6 total outcomes. That gives us 0.16666 repeating probability. I round to the nearest hundredth, 0.17, which is a 17% chance that I'm going to be rolling a 1. This is the same for each side, as there are only 1 per each side on here out of 6 total outcomes. So every side has a 17% chance of being rolled. Each side has about a 0.017 probability, 17% chance of being rolled. Let's now investigate 2. Here we're going to investigate a green die, and we're going to investigate a pink die. On the green die, it has 6 total outcomes. Fair die, each one has the same probability of coming up. Pink, same thing as well. 6 sides, 6 total outcomes, fair die. So let's play the OR game that we have. So we did, for our OR game, our OR is we have a green on 4. So that's the first thing that, oops, my bad, okay. We have a green on, a 4 on green that I have to roll, or I have to roll a 3 on pink. So there's 2 ways to win here. If I roll a 4 on green, I win, or if I roll a 3 on pink, I win. So this is the addition rule. We're going to have the probability of getting a 4 on green. We have the probability of getting a 3 on pink. Because I have 2 different ways, I'm going to add them together. 1/6 plus 1/6. We know the probability 1 out of 6. 1 out of 6. Add these. 1 plus 1 is 2. We're adding fractions. Denominator stays the same. 2 divided by 6 is 0.33333 repeating. Rounding this to the nearest hundred, turning it into a percent chance, we have a 33% chance that we're either going to land a 4 on green or a 3 on pink. You know what? That's pretty good. That's 1/3. So, you know what? I'm going to take that bet. Let's see what happens. Ah, 1 and a 5, man. Okay, let's look at and. So let's look at 4 on green and a 3 on pink. And so what this means is they have to happen together. That's pretty tough, to have to roll a 4 on pink and a 3 on green. So because they have to happen at the same time, our and is multiplication. Probability of 4 on green times probability of 3 on pink. 1/6, that's the probability of getting a 4 on the green, times 1/6, that's a probability of getting a 3 on the pink. So when we multiply it out, 1 times 1 is 1. We're multiplying. We multiply denominators as well. 1 out of 36, 0.02777. Round to the nearest hundredth, about a 0.03 probability. That means I only have a 3% chance that a 4 on the green is going to show up and a 3 on the pink. I don't know if I would take that, but you know what? Let's try. 3% chance. There's always a little chance, right? Nope. Okay. Moving on. So that's treating these dice separately. What happens on the green, what happens on the pink. Now let's bring them together. And when we do that, we're going to look at one of the main elements of the game of craps. So without further ado, let's get to investigating 2 die. So investigating 2 dice together, craps style. Now, I'm not going to teach you about the game of craps. I'm just going to be using some of the elements of it. So first, let's investigate sample space. So in craps, we're looking for the and here to come up. We're going to have on the green and on the pink at the same time. So if we look, we know that we have 6 total outcomes on green and 6 total outcomes on pink. So altogether, we should have 36 total outcomes. And that's what we're going to investigate right now. So in craps, what you look at are the sum of these faces. The faces are the actual pips. Remember, these are called pips that roll up. So these are called faces right here. So we look for the sum. So this sum would be 7. That sum would be 6. So we're looking for the sum, not necessarily, it doesn't matter the colors now. Usually in a casino, these are both white. So with little black pips. All right, but when we talk about craps, we're talking about the sum. And so what we can have is the lowest sum is 2. Now 2 are when we have 1, 2. That's it. You can't get any lower than that. There's no number lower than 1 on a die. This is actually called snake eyes. They call them snake eyes because it looks like snake eyes when the faces are up. So if we add 1 and 1, we get a sum of 2. Okay? So we add 1 and 1, and we get a sum of 2. Now we have a 3. Okay, well, how can I get a sum of 3? Well, the green could be a 1, and the pink could be a 2. This equals 3. Great. Or I could have the green having 2, and the pink has 1. That's also a sum of 3. So there's 2 different ways to get a sum of 3, a 1, 2, or 2, 1. So remember, I'm just saying the first one is what the green lands on, and the second one is what the pink lands on. Okay, let's investigate a sum of 4. Now a sum of 4, well, we can have, let's see, we can have a 1 and we can have a 3, okay? Or we can have a 3 and we can have a 1. Could be the other way around. Or, yep, you guessed it, 2 and 2. So there's 3 different ways for a sum of 4 to pop up when you roll the dice. I am now not going to go through all of them, but I am going to show you what it looks like. So here we have, there's only one way that a sum of 2, 1 and 1. 2 ways a sum of 3, 4 ways a sum of 4, 3 ways a sum of 4, 4 ways a sum of 5, 5 ways a sum of 6, 6 ways a sum of 7. Doesn't go up anywhere more than that because the highest number on the dice is 6. So we're not going to have, we can't do like 1 and 8. We can't get a 9. And then it starts going back down. So look at this. There's only one way that a sum of 12 can come up, and that's if it's 6 and 6. There's only 2 ways a sum of 11 can come up, 5 and 6 and 6 and 5. Because there's no other numbers that we can use to make those combinations. So if we count all of these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we get 36. Which, using my multiplication rule up here, same exact thing. But now you just have all of the outcomes listed. This is a really nice picture. If you want to pause the video and take a picture of this with your phone or screenshot it, it's nice to have all the combinations because that's what we're going to be using next. Okay, so finding probabilities, the sum of these 2 faces, finding those probabilities. We have to remember our first basic rule that this probability is the number of how many times that sum comes up, or the number of outcomes divided by the total number. So in this case, our total number is going to be 36. And then we're going to have to find out how many out of 36 to get our probabilities. So let's just take a look at that first one. Probability of 2. So the only way that the sum of 2 can come up is with a 1 and a 1. So there's only one way. And so we're just going to round that to 0.03. So 3% chance I'm going to get snake eyes. Okay. How about a 3? So remembering a 3 will have either a 1 and a 2 or a 2 and a 1. Gotta find my 2. There we go. So there's only 2 ways this can come up out of 36, which is about a 0.06 probability, which is about a 6% chance. Definitely much better. Okay, let's keep going. A sum of 4, well, there's 3 ways a sum of 4 can come up, 8% chance. Sum of 5, 11% chance. Sum of 6, 14% chance. Now the sum of 7 is a 17% chance. So that's where this comes in handy. Because what you notice is that 7 has the most combinations. So 7 is going to be your highest probability. Actually, it's pretty cool because if you turn like this, if you turn it like this and you put little boxes around here, this is actually a very nice little graph. You can see how the distribution happens here. Just a little something cool. So, because 7 has the most, it has 6. 1, 2, 3, 4, 5, 6. 6 out of a total of 36, I'm going to have a 17% chance that that comes up. So if you're playing die with somebody and you have 2 die and you want the highest probability, you better say, I'm going to be choosing a sum of 7 because that has the most combinations, which has the highest probability. After that, it just starts going back down. Sum of 8 goes back to 14, 9 goes back to 11%, 10 goes back to 8%, so on and so forth. So if you notice, this is a pretty symmetric distribution. We have 3 and 3, 6 and 6, 8 and 8. The highest peak is that 7. Okay, so here's your probabilities. This is another nice picture to take. A lot of professors in college teach you about probabilities of rolling 2 die, and this is nice to have on hand because everything is laid out in front of you. Okay, let's move on. So in the game of craps, there is something called pass the line or don't pass the bar. So I'm not going to tell you about it, but if you want to Google it, go for it and you can learn it from there. But don't pass the line or don't pass the bar really is talking about rolling a 7 or 11. If you roll a 7 or 11, you may win. If you roll a 7 or 11, you may lose. But it must have to do with 7 being the highest probability. So let's say for this case, I want to win. Okay. So if I want to win, I'm gonna bet on the 7 or the 11. So that means that a sum of 7 or 11 has to come up. So we're looking at perfect. There, I would have won. So let's see what the probability of me winning. So the sum of 7, 6 out of 36, because there's 6 different ways. All right, sum of 11, 2 out of 36. Now remember, it's 7 or 11, so I have 2 different choices here. And in my first choice, there's 6 different ways. In my second choice, there's 2 different ways. That gives me a total of 8 different ways out of 36, which means there's a 22% chance of rolling a sum of 7 or 11. All right, not bad. Almost 25%. Not bad. Okay, let's look at the next one. These numbers are also very important to pass the line or don't pass the bar. Again, you can Google it. I just wanted to give you a little tidbit here or there that this is what it's dependent upon. So it's the probability of a 2 or 3 or 12. So if we have the probability of a 2 or 3 or 12, I now have 3 different ways to win. Okay. So, probability of a 2, there's only 1 way out of 36. Probability of a 3, there's only 2 ways out of 36. And probability of a 12, there's only 1 way out of 36. So if we add the numerators together and keep the denominator, we see that we have a 4 to 36 chance, or 0.11 probability, that we are going to roll a sum of 2 or 3 or 12. Ooh, 11%. I don't know. So you know what? I'm going to take, let's see, which bet am I going to take? I'm thinking I'm going to take my 22%. So I'm going to be the person that's going to put the money on having the 7 or 11 rolled. Okay, so I'm going for it. Here we go. All my money's down. My money's down. Ooh, hold on, let me roll it back. I got a 5, a sum of 5. So didn't win. Dealer takes my money. I'm all cashed out. I'm all done now. Okay. So this has been probability with rolling 2 dice. First, we investigated if we had the probabilities as separate die, as a green and pink. Then we investigated some of the foundations of craps, which is to put them together and treat it as a sum. Hopefully this enlightened you a little bit. Hopefully you know now what number to bet upon. If somebody comes up to you with 2 dice, definitely go for the 7. And this is Dr. Mears. Talk to you soon.